going to get started with absolute value equations. Part 2 of this lesson is absolute value inequalities. In this first part, though, we will just look at how to solve for the absolute value of a number. There's some basic rules that absolute value equations follow. First of all, absolute value is denoted, like on this top line right here, with giant bars almost around the x. So here we have absolute value of x equals k. In this case, k just represents some constant number. It could be absolute value equals 4, absolute value equals 5, anything that's a positive number. That's what the second parenthesis says. K must be greater than 0. Absolute value simply means that it's going to be the positive spin of that number. So if you have an equation that says absolute value of x equals some number where the number is greater than 0, you're going to solve that equation by writing an equivalent equation like we have here in the middle. So we would first solve it by saying that whatever's in the absolute value set equals a positive number, or it could equal a negative number. Because anytime I stick a negative number in the absolute value symbol, I pop out a positive number. To write my solution set, I write it in curly braces with a negative k, comma, positive k. On the second type of example, we have absolute value of x equals 0. An equivalent equation to that is x equals 0. The only solution set for absolute value of x equal to 0 is the number 0. Finally, in the third generalization or formula that we have up here, we have the absolute value of x equals k, another constant number, but this time k is less than 0. So an example of that might be absolute value of x equals a negative 2. Remember I told you every time you put something in the absolute value, it pops out a positive number. So you could never put anything in the absolute value symbol that would make it go negative. This up here says that distance cannot be negative, because we're going to look at it in just a minute on a number line. But really, you could change this to the absolute value of x cannot be negative. If you see an equation that looks like this, the only solution set that you would have to it would be the empty set. So if you were asked to solve an equation that looked like absolute value of 3x minus 4 equals 12. Over here, k, in this case, is a 12. 12 is certainly bigger than 0, so k is positive. So if you remember on this chart over here, we said we're going to write it two ways. One time we're going to write it positive. The next time we're writing it negative. So let's look at that. Already I have typed up here 3x minus 4 equals a positive 12, or 3x minus 4 equals a negative 12. Now I know what you're thinking, absolute value can't be negative. No, we're just looking for two numbers that you can plug into this and get a positive 12 as your answer. So let's see, we're going to solve the equation on the left by adding 4 to both sides. I get 3x equals 16. Divide by 3, x must equal 16 over 3. Or, I go to the equation on the right, add 4 to both sides. I get 3x equals negative 8. X must equal negative 8 over 3. How do I write my solution set? I use the curly braces, negative 8 over 3, comma 16 over 3. I know you're thinking already, oh, but wait, it equals a negative number. So automatically we're going to say empty set. We're not quite sure about that. It does appear that it might be an empty set. But first we must isolate the absolute value equation. What does that mean? That means get it by itself. Right now there's a 4 hanging out in the front, actually attached by addition. So we're going to subtract the 4 from both sides. I've got negative 3 times the absolute value of x minus 2 equals negative 12. Still, there's a negative sitting out on the right. You're tempted to stop there, but you can't. You must divide by what's attached to the absolute value. In this case, attached to the absolute value is a negative 3. So we're going to divide by negative 3 on both sides. These cross out. I've got the absolute value of x minus 2 equals a positive 4. Now the absolute value equation is sitting all by itself on the left. It's been isolated. Now let's evaluate the right. Is it positive or negative? Of course, this 4 is positive. So we can solve it. How do we solve it? We write it one way positive, x minus 2 equals 4, or one way negative, x minus 2 equals negative 4. Solve the two equations. Add 2 here on the left. X equals 6. Or add 2 on the right. X must equal negative 2. My solution set, being curly braces, negative 2, comma, 6. This is the same type of thing. Let's look at it one more time. Got a negative 5 times the absolute value of 3x minus 7 plus 4 equals 14. I have to isolate the absolute value equation. I do that by subtracting 4 on both sides. I've got negative 5 times 3x minus 7 equals 10. Divide by the number attached to the absolute value of 3x minus 7, which in this case is negative 5. I've got the absolute value of 3x minus 7 equals negative 2. It's important to note that k in this case is negative. Because the absolute value cannot be negative, the answer is the empty set. You have something that looks a little strange, like this particular problem. We have absolute value on both sides. If you notice, the absolute value on the left is just hanging out there by itself. There's nothing being added, subtracted, multiplied, or divided. So I do not change the left. I write the right as a positive, or not changing the left again, I write the right side of the equation as a negative. I'm going to distribute the negative through the right-hand side. Got negative 3 plus x. Now I'm ready to solve. Over here on the left, I'm going to take all of my variables to the left and all of my numbers to the right. I'm going to do that by adding x. Adding x, I end up with 2x minus 3 equals 3. Add 3. Got 2x equals 6. Divide by 2. X must equal 3. I want to move all of my letters to the left, all of my numbers to the right. So I'm going to say minus x minus x. X minus x is 0. So now I'm going to have negative 3 equals negative 3 is a positive 3.